Okay, well, we'll go ahead and get started. It's 3:01. I want to welcome all of you. Thank you for coming, making the trek over to Tech Square. And this is a new area. We sort of outgrew our seminar area last week.
Problem to have.
Yeah, so we're continuing to expand. So, and we actually have another place we can expand into. A room behind here, and if you were here during COVID, you know that there was a lot of spitting or expectoration going on back in that other room back there. So, but I think it's all cleaned up and we're all good. And but we may be furthering to expand, and as we continue to grow, we'll look for other venues. Before we get started, I just want to mention that usually our seminar series is on the second and fourth Thursday of each month, but next month will actually be on the first, third, and fifth Thursdays, because there are 5 Thursdays in this year's March, and also the fourth Thursday is during spring break. So just to throw a curveball in there. And our next 2 speakers, one will be Julian Tang. Julian is a new faculty member. She just joined Georgia Tech recently from the University of Florida. She'll be talking about data-driven waste valorization processes for biochemicals and functional biomaterials. And then 2 weeks after that, on March 16th, will be Marilyn Brown from the School of Public Policy. And Marilyn will be talking about how willing are consumers to purchase electric vehicles, solar panels, and heat pumps, which is actually a very good segue into our topical discussion today, because our first speaker is going to be Oliver Chapman, who is a Ph.D. student in the School of Public Policy working with Marilyn Brown. He'll be talking about activating climate solutions in Georgia. And then he'll be followed by Megan Conville, Social Sustainability at Stake, Landlords' Roles in Manufacturing Community. Megan is a PhD student in the School of City and Regional Planning. Will be followed online by Carlos Fernandez, who's actually calling in from Boulder, Colorado. Is that right? Boulder or Denver? Boulder. Yeah, Boulder. Yeah, he's currently at the National Renewable Energy Lab, but he is normally a student in the School of Mechanical Engineering. We'll be talking today about achieving decentralized, electrified, and decarbonized ammonia production. We'll be followed by Olanike Olamo. She is a PhD student in the School of History and Sociology. She'll be talking about a project that she actually did when she was a graduate student at Auburn University. She'll be talking about the Sustainable Livelihood Framework to analyze gender participation in the Nigerian cassava value chain. She'll be followed by Sarah Roney, a PhD student in the School of Biological Sciences, but she's actually pursuing a degree in ocean science and engineering. She'll be talking about using predator chemical cues to strengthen Georgia's oyster reefs. And then finally will be Vishal Sharma, talking about sustainability in and through information and communication technologies. Vishal is a PhD student in the School of Interactive Computing, not commuting. Our format today is going to be a little bit different. There's no slides. They're going to talk in sort of a lightning round kind of format, very conversational, sort of 7 minutes. When they finish their 7 minutes, we'll be free to ask them any questions, or just be thinking about how maybe your research connects with their research, or their interests. And that's really what our IRI, interdisciplinary research, is about sort of making connections and sort of thinking about new ways in which we can apply maybe existing processes, algorithms, technologies sort of in one area to provide benefit in another area. And that's usually where a ripe area for innovation is, almost easy pickings for innovation, if you will. So with that, I will let Oliver Chapman sort of kick us off, and we'll see where we go from there.
Thank you. So I'm going to kind of, instead of talking specifically about one paper or project I'm working on, I'm going to kind of give an overview of kind of the research I've been doing in the past and kind of what I'm looking towards in the future. This talk's actually come at quite a good time, and I've just wrapped up a couple of projects and I'm looking to start a few ones now. So just a bit of overview. My name's Oliver Chapman. I'm a second year in the School of Public Policy, working with Dr. Marilyn Brown. Before joining Brook Byers, I spent 2 years working with the Drawdown Georgia project, looking at kind of localized climate solutions, and that's been a big kind of emphasis on the research I've done looking forward, is how do we localize climate solutions to specific economic and geographic regions, and how might those look different to other regions? So from that, I was looking at kind of specifically the state of Georgia and how what specific climate solutions might look like in that state, and kind of how they would impact us in terms of job creation, emissions reduction, economic output, as well as equity implications and some electricity prices and so on. And from that, I got interested in kind of how households in the residential sector interact with energy in terms of the energy they use, and from demand response to home heating to kind of the usual suspects of rooftop solar and EVs. And it got me interested in kind of how do households interact with different potential solutions. And I was fortunate enough to work with Dr. Brown and a few others from UGA and Georgia Tech on this survey, looking at how people's attitudes towards certain climate technologies and climate change in general were in Georgia. And the three technologies we looked at were rooftop solar, EVs, and heat pumps. And whilst looking at the results, what really interested me was heat pumps, which is getting a bit more attention now. You saw that in the Inflation Reduction Act. It's getting a bit more support. But the way people viewed and the people's motivations around kind of heat pumps or just home heating and cooling was quite different to that of EVs and solar panels. As one of my colleagues mentioned, she has a Prius, and you see sometimes with people adopting solar panels, EVs, these are very visual products people have. So whilst they can save you money through your energy bills, or you're not having to spend money on gas, they can also be a good way kind of to virtual signal that you are someone who cares about the climate, someone who cares about the environment, and kind of whether that's your main motivation or it's an additional one. But that wasn't really a key motivation we found for heat pumps. Heat pumps are hidden. You don't really have house parties where you show the friends you want to check out I've got the latest heat pump.
Speak for yourself.
It's not something that wasn't really something that motivated people to adopt. It's also interesting in that a lot of people were turned off from adopting EVs and rooftop because they felt it was too, even though it could save them money, it was just too associated with kind of the liberal hype of environmentalism and that. Whereas heat pumps, because they were so much more low key, you saw a lot more conservative, less climate conscious people adopting this technology that is actually really key to states like Georgia in reducing their heating and cooling is the largest source of energy use for an individual household, and reducing that is going to be key for a state like Georgia, and kind of it's pulling its part in the fight for climate change. So moving on from the survey, and now kind of I'm at this crossroad where I'm looking at kind of heat pumps and how we can kind of characterize the individuals and the households who adopt it, and see kind of what incentivizes them, what motivates them. Largely implemented through new builds, so it's not up to the individual, it's up to the contractors. So in a state like Georgia, where there's over half of the houses were built before 1990, you've got a lot of buildings that people are just going to keep on using the same old gas or electricity system they had. They're just going to replace the same system. So how can we, I'm really interested in kind of answering the question of how can we understand how they would interact to policy. You know, we don't want to, like I mentioned, they may not be that concerned about the environment because we don't want to essentially spook them into thinking, oh, now it's just another environmental agenda. I'm not that interested in this anymore. How can we, do we emphasize, you know, the cost saving potentials or the simplicity, the fact that you only need one system to heat and cool your home? Is that done through, you know, financial incentives? Is that done through educational or just simple advertisement? Do you go to the installers, or do you go directly to the households? You know, these are kind of the questions I'm really interested in answering. If you want to finish talking, if you have any, you know, specific questions about kind of that, feel free to ask, or if you're interested in kind of what I've talked about, feel free to reach out and email me. I'm not sure how we give out our emails, but you can feel free to ask me questions afterwards as well after the talk. But yeah, that was hopefully around 5-7 minutes.
Great. You know, I have been to your advisor's house for a dinner party, and she made a big deal.
Storage.
I didn't see that this was pre-battery storage, I guess, but she did show us her heat pump.
Dr. Brown is a very rare breed in environmentalism. I would take that as the standard, but I can believe that she did.
Yeah. Any questions for Ollie?
I'm curious if you looked into as a new homeowner myself and a first-time homeowner, it's been a really hard time to buy homes, right?
Mm-hmm.
You know, interest rates and all that kind of stuff. Have you looked into and also just the cost of living is incredible. I'm wondering if you looked at socioeconomic at all, and also how changing housing markets influences these decisions as well.
Mm-hmm. We're actually interested.
I mean, a lot of people can't even do homeowners these days.
No. So yeah, that's there's a term which is escaping me.
Incentive?
Yes, where, you know, if you aren't a homeowner and you want to adopt a heat pump, sometimes it's not up to you. You know, it's, as you know, with home and heating and cooling, it's usually the landlord's responsibility, and heat pumps can be more expensive to install, even though over the long run they'll save the homeowner, the resident, you know, money in bills. But if you're not living in the property, you know, that there isn't really that incentive for the landowner the homeowner to spend more and then not receive that financial benefit through savings. So there's definitely issues there. In a state like Georgia, the exact numbers escape me, but I think it's a majority rent state, so there are more renters than homeowners in the state. So, you know, it's finding out ways to encourage, incentivize homeowners to work with renters in opening up that opportunity, so that people, and you know, if they're saving money on their bills, it can also help with things, you know, energy poverty and so on. So I think that's really an important question.
Is there is there private data about this, about increased adoption of personal homeowners versus people who are using it as a, you know, wealth?
So,
or is there any correlation at all between landowners?
So yeah, like most, the thing with heat pumps is, I mean, you care about, usually when you're buying a new home, you care about, say, the life, you know, how old is the existing system? Because you want to be thinking, am I going to have to replace this in the short or long term? But because most heat pumps in the state are from new builds, so they were installed when the house was built. It's not people making the decision to switch from a gas or an electric furnace to a heat pump. It's not really, I suppose the question you're asking is are heat pumps kind of, do they increase the price of the home, or do they play on the minds of homeowners when they're looking to buy a property? We haven't really seen it. There hasn't really been any research on that. That's something I'm definitely interested in looking
I
at.
was just saying, the rate of adoption among like primary owners of a home versus someone's second home. So
Oh,
is the rate of adoption the same?
there hasn't really been any. I haven't really seen anything in that. If I was to guess, or do an educated guess, I would say it would be higher for as your primary resident, because that's you're going to be getting the benefit of savings on your energy bills. If you're, say, a second property, either for summer or as a rental property, you're getting less of that financial incentive. And as we've seen with the survey, most people who own heat pumps or adopt heat pumps, their main motivation is the financial, not the environmental motivation. So I haven't really seen anything in that, but if I was to make an educated guess, I'd say rates are high for primary residents.
Can I ask another question, or do we need to move on?
Let's move on, and then hold your questions, and if we have time at the end, we'll circle back to it. So, Maggie.
Hello, my name is Megan. I am a third-year PhD student in the School of City and Regional Planning, and I'm here to talk to you generally about the dissertation topic that I'm looking into and why everyone should find it very exciting. I feel like as I've met other advisors throughout BBISS, there's been the question of what do you bring to the cohort? And I thought that was interesting. And I think I bring this element of social sustainability that has yet to be as topical to this concept of sustainability as widely understood. And social sustainability specifically involves this construction of community, discrimination, equity, and my area of focus is affordable housing. Specifically, I look at discrimination and access to affordable housing. So this is a very unexplored topic, generally, just landlords, tenant selection, this sort of thing. And there's a concept around landlords that they can actually manufacture community, which is really interesting. So you've got mom and pop landlords who may own 1, 2 homes that they rent out to other people, but then you have landlords who own 50, 60 buildings, apartment buildings, and they can manufacture community. So it's a question of who is applying. We don't know who's applying. Then there's this big mystery in the meantime. We don't know what processes they go through to select people. And at the end, you get folks in the housing. So as a bit of background, I used to work in homelessness prevention in Seattle, and I was noticing that we were having a lot of issue getting our lowest income tenants into housing. And I thought there has to be this sort of element of income discrimination, where if you're saying we're allowing people between 30 to 60% AMI, you're probably going to start selecting people at 60% AMI. You're not going to be choosing the people who are at 30 because they're able to contribute more rent. And of course, the moment you start looking into things like income discrimination, you start hitting every other type of discrimination that exists on the face of the planet. So there's a lot of unanswered questions in this field of tenant selection. It's also very topical right now because during COVID, there was, as famously, the wave of evictions, right? We all heard about the wave of evictions that happened, which there was a wave of formal evictions. There was a consistent, ongoing informal eviction process during COVID. But as this sort of awareness of evictions has come up, especially with Matthew Desmond's book, Evicted, which was a Pulitzer Prize winner, give it a read if you have a chance. It's very depressing, but also very good. And folks start to wonder also, who is getting evicted? And then as they started to think who is getting evicted, they were also thinking, well, who's even living in these units? And so there's a lot of questions out there with this. And so my area of research has to do with concepts of discrimination. And so now I'm going to break it down for between how it looks for small landlords and large landlords, because that's going to be different. Small landlords utilize individualized racism along with systemic racism. So when you're interacting with a landlord, they are able to make a judgment call on you, but then they also put you through systems of discrimination. So when they run a credit score report on you, that is a system that they utilize. That is not something that they are personally constructing. But then you have big landlords. And this is the thing that I think everyone either has experience doing this or has a friend that's done this, where they go to apply to something and they just tippity type in their information, and then you pay like $4 million for no reason. You press enter, and then you find out at some point if you have the house or not. No one knows what is going on with the software in the background. No one has, and when I say no one, I mean the person applying, right? Most of us have no idea what's going on behind the scenes. There's a lot of questions about the software, and especially in cities like Atlanta, where corporate land ownership is like through the roof, where a lot of it's big homeowners, there's not as many mom and pop landlords here. There's this increasing sort of emphasis and question on what is happening with the software. So the area of interest that I'm going into is going to be looking at these sort of systems that your information goes into, what comes out. I'm also curious how folks find out about housing opportunities. Legally, can I just go to my friends and I'm like, you should just apply. That would be really cool. And then one person applies and I accept them. Or is it sort of an open forum? Is there a sort of, I know with affordable housing, there are legal guidelines, but I'm curious to see how the general person finds out about housing. So lots of questions, almost no answers. Very happy to bring that to you here today. But please let me know if you have any questions about my area of interest. Yes.
Hi, I'm Anne. I'm with the Office of Sustainability. Thanks for having me. Affordable housing is kind of like a side just interest of mine, and I've sat in on neighborhood meetings and studied the Atlanta kind of marketplace for affordable housing. My partner is kind of in the process of starting a nonprofit around affordable housing, so I really appreciate that you're studying this. My question is around whether or not your research is interested in studying discrimination at the neighborhood community level of how affordable housing is perceived through the community-based like neighborhood districts that actually like accept or reject whether or not affordable housing can be built. And then my second question about discrimination for you is, if you're going to be evaluating the Atlanta Housing Authority as a hub for that intake process, and you may or may not know that like they haven't built affordable housing in like decades. So maybe I'll leave it at that. Are those two areas part of how you're looking at the problem of discrimination and the process of the development cycle of affordable housing?
So I'm not specifically looking at this idea of who accepts or rejects affordable housing. However, it does actually feed into the wider picture. While that is not my area of interest, that does feed into the way that landlords feel that they need to cater. There's existing research on this, so I am not the authority on this one, but I am happy to report that there's research that landlords feel the need to appease sort of the perception of affordable housing. And so there's this idea that they accept who they consider deserving. There's a wide swath of what like folks are considered deserving, what qualifies people as deserving, but there's this overarching conversation within mom and pop landlords who operate affordable housing that they continue to use the word deserving. So I do believe that in areas where they have a harder time establishing affordable housing, there may be a little bit more tension in trying to cater a community that would quote unquote appeal to others, whatever that may look like. And in the second range of affordable housing, I believe also the conversation about why affordable housing isn't being built, it does feed into looking at Atlanta generally, because I think on a wider scale, it's a question of what are the barriers that are put up to creating affordable housing in the city. I don't believe I'm going to be looking as much into the process of creation. It's more that after creation has happened, they are placed in service. What happens after that? But all the conversations leading up to that point are still relevant to the way that people behave afterwards. So those are all very relevant points. Thank you. Oh, I don't know. I'm so sorry.
So great topic, very interested in it. I'm just curious, since you say you want to study these software that are provided for selecting who receive the housing, how might you plan to get at this if the corporations themselves won't tell you?
That is a great question, and that's definitely going to be an issue we run into. I do believe that one way to go about circumventing it, sort of, is just to observe a housing intake process. right? So even if you don't know what's going on with software, you start getting insight into what information is being collected, what demographic information is being input, and then what is coming out at the other end. Because at this point, we don't even know landlords don't keep records of who's applied. And so there needs to be sort of that insight into who is even applying, even if we don't know what's happening in the middle with the algorithm. So it'd be interesting. There are elements of information to be collected because this is just like, once again, widely unexplored field, where if I don't find out what's happening with the actual software itself, at least we get some insight into who's applying and what is it spitting out at the end.
Let's, in the interest of time, keep moving along because we do have 4 more speakers to cover. We're going to jump to Carlos Fernandez, coming to us from Boulder, Colorado, and recognize also that his advisors here in the room with us, Marta Hatzel. I think Carlos was studying the panoramic view above us to see that you were here, but I thought I saw him earlier. So Carlos, take it away.
Yeah, hello everyone. So thank you for the introduction. I'm Carlos Fernandez. I work in Dr. Marta Hatzel's lab, and today I'll be talking mostly about ammonia, and then I'll switch paces and I'll talk a little bit about the work that I'm doing right now. So why ammonia? Why we're looking at ammonia? It's a giant chemical. It's one of the biggest chemicals in terms of production, and it emits about 2% of all the CO2 emissions in the world, and also consumes about 2% of all the energy that is consumed in the world. What I'm trying to do with my dissertation is look at the deployment of renewable strategies to decarbonize the current Haber-Bosch process, which is the process that is used to produce ammonia. This process is, first of all, giant in the scale of thousands of tons per day, and it mostly works by using natural gas as the hydrogen source. So we're looking at 3 ways that we can use to decarbonize ammonia. The first one is coupling the existing process with carbon capture afterwards. You can also kind of alter the Haber-Bosch process slightly and change the hydrogen source from methane to water. And you can electrify the process to make it so that you reduce or eliminate most of the CO2 emissions. And the third way that you can decarbonize ammonia is going the electrochemical route, which is how we started this whole project, which is one of the early stages of the technology, and it's unproven and it might not work. But the first thing that I'm doing is looking at the deployment of these electrochemical technologies in a global scale. So what I did is I built a distribution model, and I'm able to place facilities all around the world to minimize costs, minimize distribution distance, and also minimize the impact that these facilities have on the water infrastructure on the world, while still taking fertilizers from production facilities to the farms. We did this initially with electrochemical technologies because they can be scaled down to very decentralized scales. However, moving forward, what we're looking at the deployment of technologies that have been proven, which the only technology that has been proven is the Haber-Bosch facilities. And what we're looking is how the economics of turning existing Haber-Bosch plants to decarbonize Haber-Bosch plants, either through carbon capture or electrification through water electrolysis, how these economics work at different lifetimes of the facilities. How do these economics work with different incentives, carbon taxes, and incentives for renewable ammonia? And another thing that we're planning on looking on in the future is how both of these 3 technologies can be coupled with renewable electricity sources, because solar and wind are pretty intermittent. And these facilities in general are the opposite. They have very long starting times. They take, days to turn on, days to turn off. So we want to know what the best way to, couple these facilities with wind and solar are, and if it's even feasible. And now to do a completely 180 and change a little bit of my other aspect of my research, which is what I'm doing right now. These electrochemical technologies to produce new chemicals, they will need first new materials, they need new membranes, new polymers, It's a completely new chemistry that hasn't really been implemented. So what I'm doing right now here in NREL is we're looking at membranes, and these membranes are pretty, they haven't been studied very well. So what we're looking is we're looking at the properties of these membranes, at the structure, and then we're immersing it on some of the intermediates and the chemicals that they would experience in these chemistries. And we're looking at how the structure of this membrane changes throughout time and with these different materials. The idea is that by looking at the structure using spectral electrochemistry, we can look at how these membranes degrade, let's say, when they're exposed to alcohols, when they're exposed to ammonia, when they're exposed to nitrates. And by doing that, we can understand what portions of the membranes break down. If it's the chains, the salt, maybe there's some ion exchange that breaks the membranes, and then we can give that information to polymer scientists, and we can help them make better materials for the future of the chemical industry. So as you can see, I mean, my research goes anywhere from distribution modeling, distribution optimization, to techno-economics and product modeling, to material science and understanding how the materials that we're using on these processes work. So yeah, that's kind of a big overview of what I have done, what I'm doing, and what I'm planning to do. And yeah, if you have any questions, feel free to ask.
Thank you, Carlos. Any questions?
Behind you.
Yeah, please. Sure.
Hi, Carlos. That's very interesting, and very interesting range also. Can you step us back to, before the original problem definition of what is the main motivation and what's the problem that you're trying to solve by looking at it at distributed ammonia production?
Yeah. So what I was looking with this electrochemical, sorry, I'm getting some feedback. With this electrochemical ammonia production on a distributed scale, is that, if we're shifting the ammonia industry to electrochemical industry, we're likely going to have a totally different distribution and a totally different way in which we produce and distribute chemicals. So what I wanted to do this project is understand kind of the optimal regions in the world that might become major hubs of electrochemical chemicals. Because, for example, right now for ammonia, you mostly have your facilities located near natural gas resources. So you have a lot of facilities in the US, you have some facilities in Europe. But what I was trying to see is where the investment might go that might lead to kind of an optimal lower cost of ammonia production. So just trying to determine what the major global hubs for electrified chemicals might be in maybe 5 decades or a whole century from now. So just like trying to see how the chemical industry might restructure as we move to electrified approaches.
Thank you. And optimal from the perspective of who's the decision maker?
Yeah, so in this project, what we optimize based on costs and water stress. So mostly just from a global perspective, looking at optimizing the costs of producing and distributing ammonia to each one of the farms in the world. But there's a lot of assumptions that we took out in terms of, policy and infrastructure, but we try to include water stress because ammonia production is going to require a lot of water as you decarbonize it. And we took into consideration renewable resources, so solar and wind. We took into consideration, like existing infrastructure. So we didn't place facilities in locations that were not feasible to be built. And we took into consideration the, solar profiles and wind profiles to make sure that, we achieve the lowest costs while still maintaining some sort of feasibility.
Thank you.
Thank you, Carlos. Olenike, why don't we move on?
Sure.
Go ahead.
Hi everyone, my name is Olanike Olaomo and I'm a first-year PhD student in history and in the College of History and Sociology. So I'll be talking about my master's thesis, where I analyzed the gender participation in the marketing and processing phase of the Nigerian cassava value chain. So the cassava in Nigeria is cassava and cassava-based products in Nigeria, like there is staple food that almost every household in Nigeria, like almost every household, consume one cassava-based product on a daily basis. So the main actors in the value chain, in the Nigerian cassava value chain, consist of the input suppliers, the cassava farmers, the processors, the traders, transporters, consumers, and finally the consumers. So, and also in the value chain, there is a considerable gender specialization where men they specialize in fresh fruits, in cassava fresh fruits, and the women they are mainly they are mainly the processors, the small scale processors. They process the traditional cassava products, and the small scale processing is actually they do this on a small scale, and this leaves them at the bottom of the value chain as probably as unpaid laborers. And so like the women basically remain they remain at the bottom of the agricultural commodities value chain. So why I did this project is because I'm interested in international agriculture development, and I wanted to examine gender participation in the processing and marketing phases of the value chain and how this like affects the genders differently. So I did this so that we can identify to reach the poorest and the vulnerable women for transformative impacts, and also to identify where the poor households and the women where they are more present, where they are already present in the value chain, and also where they could easily integrate. The study we used a survey conducted by International Institute of Tropical Agriculture in Nigeria. Like they surveyed 952 respondents, and out of which 221 were women. And also for the theoretical framework, we used the sustainable livelihood approach. So I'm basically going to be talking about like the human capital aspect of the sustainable livelihood approach, how the women, how the Nigerian farmers have been using the cassava value chain as an alternative economic source. So the sustainable livelihood framework like is a tool that identifies how the poor rural households, how they use their assets to manage shocks and how their choices are sustainable. So so the capital assets I'm talking about involve like the financial capital, human, natural, physical, and social capital. So how they use this to develop livelihood strategies and how this transform into policies. So we are treating the outcome of so we treated the outcome of the marketing and processing phase as, like I said, as an alternative activity that can bring improved well-being among the resource poor women. So I'm focusing mainly on the vulnerability context of the sustainable livelihood approach. And like I said, the capital assets that the rural poor draw upon, like that they use as a source of livelihood, like include human, social, physical. So in this study, based on the human assets that they use, we find that household size was significant for the male. So the main predictors for men, like the main motivating factors for men, like what motivates them to want to maybe participate in the processing or the marketing phase include whether they are the primary decision maker, like their level of education, whether their marital status, and of course their household size. While it's a different case for the women. The major predictors for women is depends on whether they are producing cassava, whether they are farming cassava, and also the quantity of cassava that they harvest. So the implication is that the men, like the male-headed households with the larger household sizes, like they have more hands, more family to support them, and so consequently cushioning the effects of any form of shock or seasonality or like vulnerability that may threaten their livelihood strategies. So, like I said, the household size was not significant for women, and this means that they are prone to, like, they have increased vulnerability, and this will limit their scale of production and also like reduce their abilities to cope with, like, if any disaster should happen, this limits their abilities to cope with that, and this will might result into like reduced well-being for the women, food security, and also like it's basically impacts their life negatively. So also like the predictor for men, like I said, so this may also mean that it could also be due to the relationship between men and women, like which has like systematically subordinated women and some harmful cultural practices that denies women the access to owning lands. And also the findings like established a differential gender participation in the marketing and processing phases. Like men were more highly represented in the processing phase, which is more lucrative. Like they do it on a large scale. For instance, the high quality cassava flour. So currently there's a policy by the government that for the flour producers in Nigeria to include a certain percentage of cassava flour in their flour production. So, and it has been like, so basically the Nigerian situation is that the men with the large scale cassava production are the ones like enjoying the dividend of this emergent profitable node of the cassava value chain. And so like they have a higher representation in the processing phase than the women. So like analyzing the broader context, like the gender participation in the value chain, help us to understand women, like the different roles they play, and also like create a kind of level playing field for them economically, as well as identify some areas where like to come in policy-wise, where maybe where discrimination is more pronounced, and also the challenges that the women face. So that's my findings, and like part of the findings that has to do with the human capital aspects of the sustainable livelihood framework. And
yeah, thank you. Yeah, that's great. Thank you. I also mentioned Olaniki's advisor is here. Kate Pride Brown is.
Dr. Brown.
Yeah, she's here in the room with us. So we have time. I mean, maybe for just one very brief question. Yeah.
I just want to connect you maybe to, if you're not connected, Tiffany Brown in China College of Business, because she's working with an NGO that's looking at the history of the development of the cocoa, I think, supply chain in whichever countries.
Maybe Ghana.
Yeah, it could be, yeah. So I thought that since you have this historical perspective and gender perspective, and she does too, that you might find it interesting to connect.
Thank you very much.
I can put you in touch.
Great, thank you. Let's move on to Sarah, and Sarah is in the School of Biological Sciences, and her advisor is actually also present virtually, Mark Weisberg. So we'll let you handle any connections there.
Cool, thank you. My name is Sarah Roney. I'm a fourth-year PhD candidate in ocean science and engineering, but like Mike said, I'm housed in the biology department or school. The gist of my research is that I use predator chemical cues to strengthen Georgia's oysters, like Mike said at the beginning. And really the basis for this is understanding how we can use our perception of chemical ecology to conserve and restore ecosystems in Georgia. So oysters are a really critical ecosystem, not only in Georgia, but throughout the United States. They provide lots of habitat for other species. They're what we call an ecosystem engineer. They themselves use their body to form an ecosystem that dozens of other species can live in. And they're also economically important. How many of you guys eat oysters, right? And go to a restaurant and look forward to ordering oysters. Unfortunately, oysters have declined significantly over the past couple decades due to things like overfishing, storms, climate change, lots of different reasons. But there's estimates that oysters have declined almost 85% in their wild populations throughout the United States. And so this project has really taken this look at chemical ecology, so understanding how oysters are interacting chemically with the species that are around them. And how do we take a look into that and use that to restore these reefs and restore this ecosystem? So oysters are a really important basal prey resource, so a really basic part of the food chain that they're being eaten by other species constantly. Because of that, they've kind of evolved this ability to defend against predation by strengthening their shells. So oysters have the ability to sense chemicals in the water around them. So when these chemicals are in the water, oysters sense fear and sense that there's a danger of being eaten and dying. And so they actually take time to strengthen their shell in hopes of not dying and not being crushed and eaten. And so what my research has looked at is kind of threefold with this relationship. First of all, we've looked at what are the chemicals that are doing this? So what are the chemicals that are causing this response? And that's what I've been working on for the past 3 or so years, is actually identifying these chemicals with some chemistry collaborators and figuring out things like what concentrations they need to be at, what the response is at certain concentrations, how long this response takes. And so we've actually got a paper coming out about that soon, which is really exciting. But now the next step of this is figuring out, now that we know kind of the concentrations of these chemicals, what the chemicals are, how long this takes, how do we apply this to Georgia? So I've actually partnered with Georgia Department of Natural Resources to plan a reef restoration project here in Georgia. And the goal is that this project will use these strengthened oysters, where we've kind of developed this really nice, easy solution that a hatchery manager that's raising oyster spat for restoration can just go in, put this chemical in their tanks where they're raising oysters and grow them for a few weeks, put these oysters out into a restored reef, and hopefully have significantly less or reduced loss of oysters from predation. Predation is a major limiting factor when we're restoring reefs in Georgia, because when you're putting out oysters, they're really small, which can mean they're much more vulnerable to predation. So that is a really exciting project that I've got coming up this spring, is not only looking at how we can apply these chemicals to create quote unquote better restored reefs and more successful restored reefs, but also figuring out how we can use these reef restoration projects to prevent things like coastal erosion in Georgia. This is especially important in the Savannah area because of the shipping ports in Savannah, which are a major shipping harbor for all of the US. And have tons of massive shipping barges coming in and out of the Savannah River all day long, which is causing significant erosion on the banks of the Savannah River. So that's another exciting part of this, is looking at how can we use these oyster reefs, which are a hard substrate, essentially thousands and thousands of oyster shells barriering the, or armoring the banks of the Savannah River to prevent things like erosion. So that's kind of my research in a nutshell, or an oyster shell. And I'm happy to answer any questions on it.
Question. I can't help but not ask this question because we have so many people in the room, but the connection between fertilizers and oysters and these chemical signals, and what's up with all that? I mean, what's the answer? I mean, you got one guy who's wants to distribute ammonia production all over the place. And I imagine other parties want to get rid of ammonia production everywhere.
The amount of chemicals in natural ocean water is astonishing, like thousands and thousands and thousands of chemicals in natural ocean water, right? So when oysters are existing in the wild and feeding, they're filtering all this water, right? And they're filtering all the algae out of it. That's how they feed. And so they're coming in contact with these chemicals constantly. And it's really well documented that oysters are very sensitive to things like pollutants, like pesticides and fertilizer runoff, even like hormones. There's been some studies of like increased use of like hormonal birth control in the United States has been really sensitive to not only oysters, but fish as well. So it's a really complex issue when we're talking about these chemicals in the water. What we do know is that we've identified chemicals that strengthen oysters, that it works, and that we can use that to kind of restore these ecosystems and to armor shorelines. But it's incredibly complex when we talk about things like fertilizer runoff and agriculture runoff and things like that in the water. So. Yeah.
Is the port in Georgia that's being, developed a risk to the ecosystem further in the context of what you're trying to get?
I think when you have heavy boating traffic like that, I mean, these ships are massive. There's a risk of things like erosion, which has been really well documented by an engineering collaborator that I'm working with. I think there's always risk of like things like tourism. They're talking about expanding the harbor for cruise ships down in Savannah. So that's definitely a little bit scary when we're talking about oyster reefs, which are really vulnerable to not only boating traffic and energetic demands, but like sedimentation would be a big risk if we're dredging the harbor there. So there's definitely aspects that should be considered when you're thinking about the Savannah port and thinking about potentially expanding it or increasing traffic there.
All right, we had one comment online. Mark, you want to unmute and go?
Yeah, I've unmuted. I think one of the things that's really interesting about Georgia is that they've been much better about preserving these kinds of intertidal habitats than a variety of other states. And so, particularly in, places that are basically north of Virginia have not done this as well. There used to be billions of oysters in the Chesapeake, literally, and in New York Harbor. And, all of that was either over harvested or reduced as a result of the sorts of things that Sarah had mentioned earlier on. And so from a conservation perspective, Georgia and the Southeast in general are particularly good hotspots for this kind of work because the largest sort of natural oyster reefs that we know of in the United States are located in South Carolina and Georgia, and a little bit in Texas, right? There are no native oysters left in the Pacific Northwest. There are very few native oysters left in the Northeast. And so we have a really good opportunity to keep the ecosystems that we have now relatively intact, and work that Sarah is doing hopefully will help us do that.
Thank you. Thank you. let's move on because we are just about out of time. Our last talk will be from Vishal Sharma, and I want to welcome his advisor, Neha Kumar, is actually here, and I know she's late for another appointment, so I appreciate her hanging around.
Actually, I told my students that I was going to wait till my students is done.
Good. Thank you. So Vishal, take it away.
Yeah. Hello everyone, my name is Vishal. I am a fourth year PhD student in interactive computing. So my work basically lies at the intersection of HCI and sustainability. So HCI is this area within computing where we study user interactions with digital technologies so that we can create more human-centered, user-centered systems. So the questions, two broad questions that I have asked or have been asking with my PhD dissertation is, how can we design more sustainable digital technologies? And how can the digital technologies we design help with sustainable living, or like motivate people to become more sustainable, to move towards more sustainable practices in their daily life? And the first question that I ask is like, how can we design sustainable living is based on the growing conversations within computing, where people have started talking about and critiquing the design of computing technologies, because now the technologies we design like AI and all of these like fancy technologies, they consume a lot of resources. For example, just as an example, like if you have to train one single natural language processing models, it might take like 600, it might generate 600 pounds of carbon dioxide, which is equivalent to what 5 cars generate in their lifetime. So that is the first question that I ask, and we have worked on exploring and understanding and answering that questions, and we found that a lot of work in computing is basically based on this ideology of like economic growth, assuming that resources are infinite and we can keep consuming more and more resources and keep designing new and new technologies without any repercussions. So we have engaged with this idea of like post-growth philosophy or degrowth philosophy, which comes from different disciplines like sociology, ecological economics, and anthropology. And we basically provide design implications and suggested ways for designers of computing technologies to make their practices or design of their technologies more sustainable. So that is the paper that we have submitted recently to a journal. The other question that I asked with my research is, how can computing technologies help people or users become more sustainable in their daily life? So to answer that question, one of the studies that I conducted was last summer in India, where we studied how farmers in rural parts of India are participating in natural resource management, and how technologies can help these farmers to have like more equitable participation in this process. And we found that there are a lot of like structural and identity-based factors like caste, which is prevalent in India, caste discrimination, caste and other like socioeconomic statuses, even educational status, that affect participation of these farmers. So there we gave implications of like how ICTs or information communication technologies can help bring or cultivate or facilitate more equitable participation in natural resource management. And with my future work, I'm basically delving more into the area of future of work, which is basically looking at how can we design more sustainable work-related technologies that could help workers who are working, let's say, remotely or like participating in hybrid work settings to become more aware of their unsustainable practices and how they can move towards more sustainable living/work.
Very good. Yeah, thank you. Any questions for Vishal?
What are the findings of the paper that you submitted?
The first one or the second?
First one.
Yeah, so that was more like a theoretical paper where we proposed like these are the ways that you can follow to design more sustainable / ecological computing technologies. Where we, for example, one way we suggested is like how in designing of these technologies, we should look at, there is this concept of like consumption corridor, where it's like you should define the minimum and maximum level of consumption that your technology design should, that you should consider in technology design. So by that, it means like these are the minimum resources that you will use, and these are the maximum, that's the cap of the resources that you will use in the technology design, and you should not go beyond that. Similarly, we also gave implications for design like curriculum in computing, where we are educating future computing professionals to have this, to basically include this ideology of like resources are not infinite, and we have to consider their finiteness in the development of technologies.
The costs of computing are not actually engaged. I mean, they're externalities, right? I mean, it's when I write an algorithm or I ask an AI chat thing to do something for me, I get the benefit, but the cost is very far away from me. I mean, I'm not even sure where the electrons came from that did that computing process, right? It's not even necessarily in my hometown or my state or my country. It can be anywhere in the world. So how do you, when those costs and benefits are so separated and there's so many layers between, how are you going to put that together such that I feel the pain when I request some computing activity or something?
Yeah, I think that's an interesting question and a hard one. So there are design around like sustainable computing, which is basically trying to address that question. For example, people have developed solar powered servers, and as a user in your end, your website will show like how much energy is remaining at the solar power server side, wherever your like website is being hosted, so that you become more aware of the energy consumption that is being consumed at that level. So yeah, I think that's a hard question, and people are looking into it because the way we think about sustainability as users is a very like lower scale than the way sustainability implications are. You know, the unsustainable practices have implications, right? Like if you are doing something unsustainable here, it might have implication in India, for example, because it gets like compounded and coming together, right? So there is work happening in that intersection. Yeah, but it's a hard problem.
Yeah, I don't know how you solve that problem.
Yeah, on that point, it's like in the battery right now, the world is like who's going to recycle batteries? Is it the consumer who owns the car, or is it, and basically it's being pushed back on the car companies? So I'm wondering, like, the car companies are going to be responsible, hopefully, for recycling their batteries. So I'm curious about the data. Is it going to be, maybe it's never going to be on the consumer, it's on the data center, they will be responsible for decarbonizing the data center? Right? And then nothing pushes down to the consumer ever?
Yeah.
Or do you push it back to the designer of the product and say you have to pay for the carbon output of the data center because you're using this much computing power or something? But that has equity implications to think about.
But I mean, at least with the batteries of car, like Brent tells me, you know, he puts new batteries in an old Prius, and then he's left with this big chunk of batteries that he doesn't know what to do with. It's piled up in his garage, right? It's piled up somewhere.
It's in his living room.
He's feeling the pain of every day he has to go and look at this big pile of batteries somewhere, and there's some storage.
Georgia has a lot of battery recycling plans, right? They're building it.
But, and I mean, even the power for these lights right here, they're at least within 500 miles of where we are right now, because that's sort of the distance in which electrical power can be transmitted. But for computing, I get the information, I get the benefit, and all that cost is who knows where. I mean, it's
Greenland.
absolutely no geographic.
The carbon of that, you know, the warehouse that stores that data center. And the carbon space of that data center is owned by a company, it's owned by something, someone, some organization, and if they give up greenhouse gas emissions, they're gonna use the greenhouse gas inventory, that's their direct, that's their responsibility to offset their scope.
Yeah, it's their net zero plan. They have to come up with
They
it.
have to do it on behalf of their own carbon emissions, and so it's covered from a carbon if they do that, but from a cost, I think you're still correct. It's the warehouse of that data center owner that pays the cost of that algorithm energy load.
So your prices might go up for us as a consumer when they have to have their net zero plan.
Right.
But until then, but it's gonna be up to them.
It's on, yeah, it's the response, it depends on how the greenhouse gas protocol outlines the, server point source of that load.
By the way, Ann is the person who's here at Georgia Tech who's responsible for figuring out our emissions footprint at Georgia Tech.
And
Is it large?
Our tuition going to go up.
No, and we're the same as a corporation.
Gas plants, so
We're the same, like in the governance
yeah, the heating
of
of the buildings. is
reporting, which is really
outside
important.
natural gas.
Well, we are 8 minutes past our deadline. Thank you all for sharing with us today. We will convene again 1 week from today for our next seminar in the series, and thank you all for coming.